In this video, we are gonna solve one problem related to the concept of mirror formula. In the problem, it is given that an object of height h is kept at point P. Okay, this is an object which is kept at point P and whose height is h. This is given to us. Height is h. It is kept at point P in front of a mirror. Now, first of all, which mirror is this? We can see that the outer surface is polished, hence this mirror is concave in nature. This mirror is concave in nature. Now, the height of the image produces h. Actually, this height is h dash. The height of the image produced is h dash. Now, in the diagram, F is the focus and C is the center of curvature. This point F is the focus and this point C is the center of curvature. This information is given to us. Now, just a minute. Now, we are moving to our first part. If the object is now moved to point C, will the height of the image now produced be less than, equal to, or greater than h? Give a reason for your answer. First of all, the object is situated at point P, hence the image of the object P will be found behind the center, as we know, and this image will be larger than the object. That means the size of the object is h and the size of the image is h dash. It is given to us in the question. So in the first part, when the object is at P, then the image will be formed at a point behind the center, and in this case the height of image will be greater than the height of object. But now in the question it is said that if the object is now moved to point C, if the object is now moved to point C from point P, there hence the object is like this. Therefore, the image of the object at C will be formed at the point C itself, and in this case the height of the image will be equal to the height of the object. Now, what it is asking the question, will the height of the image now produced be less than, equal to, or greater than h? Now, in this case, the height of the image will be equal to the height of the object. Is it clear? Now, moving on to a second part. Just a minute. If the focal length of the mirror is 20 centimeter and the distance between point P and C is 10 centimeter, determine the distance between the image produced when the object is at point P and C. Now it is saying that the focal length of this particular mirror, this distance between pole and focus, is 20 centimeter. And the distance between point P and C is 10 centimeter. Therefore, it is given to us that this distance CP is 10. Now see, if the distance between this pole, focus and pole is 20, then the distance between focus and center of curvature will also be 20. This particular distance CP is 10 centimeter, then PF will also be 10 centimeter because this complete distance is 20 centimeter. Now we have got three information over here. The first thing is that the distance between P and F is 10 centimeter. It means the distance between the object and the mirror is 30 centimeter. Now, what we have to find? We have to find the difference between the distance between the images produced when the object is kept at C and P. Now, see, when the object is at point P, at C, the image will be formed at point C itself, and the distance of this image when the object was at point C, the distance of this image from the mirror will be 20 plus 20 more, it will be 40 centimeter. And when the object is placed at point P, let us suppose that its image is forming at this point. First of all, we will calculate the image distance, this distance. Then what we will do, we will just subtract this distance from this distance 40. We will get this distance, the difference between the distance of two images. So in this case, we will use the mirror formula. The mirror formula is simple: 1 upon V plus 1 upon U is equals to 1 upon F. We have to find U is the object distance when the object was at point P. So the object distance is minus 30. 1 upon F. F is the focal length and it is 20 centimeter. As the mirror is concave, it will be minus 20. Now, solving this particular problem, we will get 1 upon V plus minus 1 upon 30 is equal to minus 1 upon 20. 1 minus 1 upon 20 plus 1 upon 30. Solving this problem over here, 1 upon V is equal to, the LCM will be 60. 60 divided by 20 is 3. 3 into minus 1 is minus 3 plus 60 divided by 30 is 2. 2 into 1 is 2. Hence, 1 upon V is equal to minus 1 upon 60. Therefore, on reciprocaling, we will get V is equal to minus 60 centimeter. It means that the image of the object situated at point P will be formed at a distance of 60 centimeter from the mirror. Okay. And when the object was at point C, its image was formed at 40 centimeter. Therefore, the distance between the images will be, the required distance will be the 60 centimeter minus 40 centimeter. The answer will be 20 centimeter will be the required distance.